Oke. Assalamualaikum warahmatullahi wabarakatuh, Pres.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, before we start our lesson today, let's pray together according to our belief. Pray, begins. Pray, finish. Okay. How are you? Are you well?
Yes, sir. Yes, sir.
Is there any student absent today?
No answer.
Okay, thank you. So in this meeting, we are going to talk about the first derivative of the algebra function. So I'm gonna share screen my PowerPoint. Wait, still on. Okay, is my share screen is clear?
Sir. Yes, sir.
Okay, this is the first derivative of algebra function and its application. Okay, before we start our lesson, there is a quote or motivation from Najwa Shihab. That is, only education can save the future. Without education, Indonesia cannot be survived. So we have to do the education in our country, and if not, we cannot survive with it. And I want you to encourage your future education, so Indonesia will make it better. Okay, for the today material, there is two topics. The first one is definition of the first derivative algebra, and then the second is algebra first derivative application. Okay, for the perception, we know that the algebraic derivative we have learned in the last meeting about the definition of it, which is in the limit form. And then this is the sum of a function, that is fx is equal to x squared plus 6x minus 8. And then if you do the definition algebraic derivative with it, in the limit form in here, we can know that the derivative of the function is equal to the limit of the fx plus h minus fx over h from x approach to 0. If I were to see on the sample function previously that in the previous slide, so it could written as following. For the f and x is equal to limit x plus x squared plus 6 times x plus h minus 3 minus x squared plus 6x minus 3 over h from x approach to 0. And then for the final, that is we get the fx and x is equal to 2x plus 6. That is from the definition. But from the definition, we can make it simple with any form of it. So there is a sum of derivative function in here. There is fx is equal to a, fx and x equal to 0, and x equal to a times x to the power of n if the derivative of it is n ax to the power of n minus 1. And from the function that f n order in here, the derivative is n times fx to the power of n minus 1 f x and x. And for the from multiplication of the function, we have the gx times hx is the derivative of it is the gx and x times hx plus gx times x and x. And then for the dividing, that is gx over xx the derivative of it is f accent x is equal to g accent x times xx minus gx times x accent x over xx squared. Okay, this is the example of it. Find the first derivative of the following algebraic function. That is fx is equal to x to the power of 6 minus 5 over 2x squared. Based on the definition of the first derivative of algebra, we get the f accent x is equal to 6 times x to the power of 5 minus 5x. So we know that in here, there is a derivative of the 6 in here, and then check back down. And then we get minus 1 of 6 in here. Same as it, we get the 2 written in here, and then 2 minus 1. So we get the function in here. And then for the fx is equal to the square root of 2x. Based on the definition of the first derivative of algebra, we get the f accent x is equal to 1 over square root of 2x. And then for the fx is equal to x to the power of 5 minus 10 to the power of 2 times square root of 4x. We get the 10 times x to the power of 4 times x to the power of 5 minus 10 times square root of 4x plus 2 over 2. 2 over square root of 2x times x to the power of 5 minus 10 to the power of 2. So from this one, we know that we can change into the 2x to the power of half, and then we break down the half into the in front of the 2x, and then we can subtract half with 1. It could be the minus half, and then we get the form. And then for this one, we can do the multiplication of the function. So suppose that is a gx, the x to the power of 5 minus 10 square, the gx, and then this the hx, the square root of 4x. From the definition previously, in here we get the g to the power g accent x to the power of xx times gx to the power of x accent x. So we get this one. Okay, sorry, my connection is okay. The next is okay. There is a several question in here. There is fx is equal to x to the power of 3 minus 6 over 5x squared plus square root of 2x plus 10. Okay, we are going to solve it, but in here, in this meeting, we are going to practice this in the GeoGebra. I'm gonna show it. GeoGebra is some application that can help us to make a graph, especially for this material that is a differentiation material. So we can know that the graph of differentiation of the function. Maybe I'm gonna stop share screen here. Okay, have you seen my screen?
Yes, sir. Yes, sir.
Okay. Then what is it? The function of it, let me say x to the power of 3. So, and x to the power of 5. Okay, I'm gonna explain for the diagram. Maybe there is the feature in here that we can write in the function, like the square root, the e form in here, the pi, the natural number, the square, and so on. And so then we get the trigonometry function in here. So this is very, very easy to make the graph in here. And it's so helpful if you do the graph in here. Well, I read this function. Maybe someone in this class want to give me the derivative of it. Okay, no one. Okay, the derivative of it, we can know that is a 3x to the power of 2, because the 3 is to the bottom down in here, and then we subtract 3 with 1, and then we get the 6 over 5 in here become 12 over 5 x times, so because this is constant in here and then this is the variable, you can just write the 2 in here, and then because the 10 in here is constant, so there is no variable in here, we can just ignore it, and then we can just write it. So this is the actual graph of it. And then if you want to make it sure which graph of your function, we can use this feature, show name and value. And then we get this one, or just maybe show name. There's G in here. So that's all. Maybe one more time, I'm gonna one more function. Yang maybe I'm gonna write it from the my PPT. And then if you want to delete it, just delete it. Suppose that we have the function x to the power of 3 plus 7x minus 10 to the power of 3. So this is the form of the function. And then the derivative of it. But actually in this graph, we can only use this one. But yes, then we can. And then automatically we have the derivative of it. But in the final test or the test of the material in this meeting, I will not allow you to do that, but do it manually. And because this is from the computer, it's not so that the definition of the derivative. Okay, I'm gonna stop sharing. And for the GeoGebra, you can open it in the web if you don't have the application in your laptop, so you can do it anywhere and anytime. But it is like the answer before. Okay, the second one, the application first derivative of algebra. So we get the application in here. There is a sum of application. Maybe I'm gonna just skip it. So the application of it, we can find the maximum value or the minimum value and the monotony of the function. We know that from the graph before we have seen, there is a sum of curve. There is some curve with a peak of it. So there is a minimum and maximum value. And then which one is a monotonic of the graph. Then we can find the maximum value and minimum value. As follow, and then the turn value as follow. Besides that, we can also find the condition of the function, is it increasing or decreasing or descending in here, increment function and descending function. With the classification f option x is greater than 0 for increment, so it will be increasing, and therefore f option is equal to a f option x is less than 0 for decreasing. Okay, I'm gonna show it again. But first, let me write it in here. I'm gonna open the GeoGebra. Is it clear, my GeoGebra? Can we use it?
Yes, sir.
Okay. So the function is x to the power of 2, 5x plus 5. And then the derivative of it is 2x minus 5. So the next is we have to find the maximum, because and the question is the maximum. We know that the maximum is in here. In here, this is the peak of the graph, and then we can do the definition of it, which is the extremum of the graph. Here we can see it's a negative 1 2.5. How can we find it? From the definition that we say the derivative of x is equal to 0. So it would be, if the gx is equal to 0, is equal to x minus 5/2, right? Okay, can you see it? So for the graph of this derivative is not being used in here, it's just for the function of it, so we can find the value of the x to find the maximum value. After this one, we can input the x is equal to 5/2. Okay, this one. So this is the maximum value of the function x squared minus 5x plus 5. So this all. From here, is there any question?
No, sir.
Is it clear?
Yes, it's clear.
Okay. Go on next to the slide. Oh, sorry. Then this is the graph that we have drawn before. Is it same with the final of the maximum value is negative 1 over 5. Then I will give you practice question in here, so you can do practice at home. But before that, I'm gonna make it group for you to do the LKPD in here. Maybe you can join my LMS in the Java classroom. I'm gonna share it. Wait a minute. Okay, I copied in the chat box. There is a link for the Google Classroom. So in there, I'm gonna show it maybe in there. There is a student worksheet, mathematics literacy test, and student worksheet 1. So there is a teaching material in here. You can download it with student worksheet 1, 2. And for this one, for this meeting, we can do the student worksheet 1. But before that, I'm gonna make you a group. Okay, maybe I'm gonna start sharing. Okay, maybe I'm gonna, oh, there is, how many participation in here? 12. Maybe I'm gonna divide it into two person each group. Oh, no, it's too much. Of four, three. So there is a four group in here. I'm gonna make a breakout room. And you can download the LKPD from the Google Classroom part 1, student worksheet part 1. Wait, I'm gonna, so there's 1, 2, and then 1. Oh, you can join in the breakout room. But before that, for the presentation, I'm gonna share the symbol so I can watch you during the discussion. So you can join the Jamboard. You can discuss in here, and for the group, you can name it for the page which one that you want to join. I'm gonna let you discussion each group. Okay. For the group one, maybe I'm gonna set this one to Jamboard in here. So you can do it in the Jamboard. For the group one, is there any problem with the question? Are you? Is there any problem?
For now, no, sir.
Okay, you can do the handwriting there in the Jamboard. I'm gonna
Yes.
join the next room. Okay, for the group two, is there any problem?
No, sir.
Okay, I'm gonna share. Have you joined the Jamboard?
Not yet.
I'm gonna share the link. You can also write in there the question, the answer or the decision of your group. Okay, if there's no any problem in here, I'm gonna next to the next group. For the group three, is there any problem?
No, sir. We have discussed about the student workshop.
Okay, have you joined the Jamboard?
Not yet, sir.
I'm gonna give you the link. You can join in the chat.
Okay, sir. Thank you.
Okay, I'm gonna leave you and please make the discussion and you can write it on the Jamboard. Maybe you can do the calculation or anything. I'm gonna go into the next group, the last group. Thank you.
Okay, thank you, sir.
Yeah. For group four, is there any problem?
No, sir.
Have you joined the Jamboard? I'm gonna keep the link of the Jamboard in here in the chat. You can join it. And you can do the calculation of writing in the Jamboard with your group.
Okay, sir. Thank you.
Okay. Yeah, I'm gonna waiting for you guys to the discussion. Okay, Kurnia, maybe you can talk with your friends and your group to come back in the main session to do the presentation.
Okay, sir.
Okay, while we waiting the participation to come back in here. So the next section is a presentation. Maybe is there one of you want to present your result for your group? Only the one person of your group the presentation. Okay, Kurnia.
Okay, sir. I will share my screen.
Okay, I will stop share.
I'm sorry, I'm still can share. my screen because of the setting maybe.
Okay, wait a minute. Okay, you can try again.
Okay, did you see my GeoGebra?
Yes.
Okay, we are from group 2 and as the presentation will show our discussion. For the problem, we have the function is 2x cubed minus 3x squared minus 12x plus 7. And in here, we need to look for the x that always decrease, the function that always decrease for x value. And for that, we will look for the first derivation of our function. By the definition, then we can get the first derivative is 6x power of 2 minus 6x minus 12. And then for looking the x always decreasing, we make our first derivative is less than 0, so our function is always decreasing. Okay, and we can see in the GeoGebra that the function is always decrease for the value x is less than 2 and greater than -1. Okay, that's all from our group. Thank you.
Okay.
Bagus.
Okay, thank you, Kurnia. Well done. Your group is very well done. So that is a good answer and good discussion for your group. And then that is a good answer. So I think that is all for this meeting. So the next is okay. So we can conclude in here. Maybe one of you want to conclude what we have learned today. Okay, just like as Kurnia present in the GeoGebra before, we know that the application of the derivative, we can find the monotonic, the minimal and maximum value, and then find the increasing and decreasing of the function. Also that before we know the application of the function, application of the derivative of the function algebra, we have to know that the definition of the derivative of algebra function that we have learned about the definition of the derivative with the limit form, and then we can do the derivative of it, and we can simplify the formula into the type into several type of formula. So that's all for today, and then for the next meeting we will try to do the contextual problem of the first derivative algebraic function and using GeoGebra in the first derivative algebraic function like that. So this is the GeoGebra is just for the introduction, and then for the next, and then for our lesson, we are going to always use the GeoGebra. So maybe you can practice it at home and do it well. So thank you. But before we end our lesson today, let's pray together according to our belief. Pray begins. Amen. Okay, thank you. And then don't forget to submit the LKPT in the Google Classroom that I have given you in the link. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir. Thank you, sir.